This is the moon. Have you ever wondered why or how the moon is covered in different sized circles? Well, these are called craters, which are formed when space rocks hit the moon. In this video, we'll be learning a bit about what they are and how to make our own craters at home. Let's first take a look at the different features of a crater that we can look out for when we make our own. First, we have the circular shape, which is called the rim, then the lines that come out of the rim, which are called rays. There's also a darker region around the ring, which is ejecta of a material that shoots out after a crater is formed. If we zoom in, we can also see the floor and the wall of the crater. Also, just to show how big craters actually are, we can zoom in even further to look at the center, seeing something called a central uplift. This is actually a small mountain created by the rebound of the moon's surface. Now let's try and recreate some of the features at home. There are a few things you'll need for this, so if you're on the 10, make sure you ask a parent or carer to help you out. So make sure you have a pan or a tray that you can use as a base with some newspaper underneath because things can get pretty messy. So firstly, you'll need some stuff to make the different layers of the moon. I'll be using some flour, some sprinkles, and some cocoa powder for the top. So firstly, adding the flour. Try and make it as even as possible. Next, we can add the sprinkles. You may also want to use a sieve to sift the cocoa powder. Now that we've got our moon surface, we need something to make our craters. So I'm going to use this Christmas ornament filled with marbles, but using different sized rocks is also fine. Now this is going to be our space rock, also known as an asteroid. So these things actually orbit the sun and sometimes gets knocked into other objects like the moon. Now we're ready to try it out. Here we can see how the impacts cause rays of material to come out and an ejecta of material around the circular rim. We can also see the wall and the floor of our crater, just there. You can also notice how the flour and the bits of sprinkle from beneath have come out. This is why astronauts pick up material near the craters to discover what lies underneath the moon's surface. Let's try this again, but with a heavier asteroid. I'm going to do this by adding more marbles to my ornament. We can see that because the rock is heavier, it has a greater force, meaning that the crater is much larger and the rays are longer. You can also notice that the ejecta is much wider as well. What do you think will happen if we throw this at an angle or use a larger rock? Try it at home and investigate the different patterns you get to see and what this tells you about the crater. We can also turn this activity into an experiment by taking measurements like how deep the crater is and how far the rays go, where you make changes to the rock or the way we drop the rock. So I'm going to change the height and also measure how far the rays go. So I'm going to set this all up again. So let's first drop this at 20 centimeters. Now let's drop it at 60 centimeters. We can measure the depth by using a stick and marking the crater's height with a marker pen, then measuring it against a ruler. I'm also going to use a ruler to measure the length of the longest ray on each crater. Make sure to write your results with units down. Let's take a look at the results that I got. When dropped at 20 centimeters, the depth was 2.5 centimeters and the length of the rays went up to 7 centimeters. But when it was dropped at 60 centimeters, the depth was 3.5 centimeters and the length of the rays went up to 10.5 centimeters. This is because at larger heights, the rock has more time to speed up, making it faster once it reaches the surface. This means that it can transfer more energy to the moon's surface. Try it at home and make some changes and measurements to see what different patterns you get. After doing this activity, you may be wondering if you've ever seen a crater on Earth. There are actually craters on the Earth, but not nearly as much as there are on the Moon. This is because the Earth has an atmosphere that burns up meteors to the point where they disintegrate, so they don't even reach the surface, or the large rocks break up into smaller ones that don't make as big an impact. The Moon doesn't have an atmosphere, so there's no protection from these asteroids. This is also why we can still see Neil Armstrong's footprint if we went to the Moon today. He was the first person to step on the Moon over 50 years ago. Because there's no atmosphere, there's no weather like wind to blow the surface, and it's not been washed away as all the water on the Moon is frozen. That being said, it's not impossible for a space rock to hit that region and form a crater, completely wiping out the footprint. This is what makes the Moon great for studying the history of its collisions, with older craters lying underneath the newer ones. You can model this at home by throwing multiple rocks on top of your Moon surface model. Because Earth has an atmosphere, it means that even the craters we do have may be filled with soil or water due to the weather. But what do you think would happen if an object so large that it doesn't entirely burn up reaches the Earth? It would create a collision so large it would throw out chunks of the Earth into space, and this is what scientists believe to have created our mysterious but wonderful Moon.